Hello everybody and welcome to our presentation of CoverZone, development of a game AI from pen and paper to C# Unity by Markus Heiss and Ralph J. Möller. This is me. Markus is going to be presenting the Unity part later on. First of all, let's talk a bit about what CoverZone is, what's the idea behind the project, and what you're going to see in the next few minutes. Well, now you should be able to see me. Hi. Well, CoverZone. Let's talk about CoverZone for a bit, how it all came to be. CoverZone was originally conceived during a seminar at the Donau-University a few years ago when we were given a task to create a game from scratch using only pen and paper, a two-dimensional grid, and whatever tokens we were able to create using only pen, paper, scissors, and some colors. And our idea was to use the grid, pretty much straightforward, to place tokens on it, and then put some kind of zone onto the grid. And if your tokens were inside the zone, you get a point. If not, no point. And who had more tokens inside the zone was the winner of the game. Here you can see our first prototype consisting of a 12 by 12 grid, a blue zone, and some tokens in white and some yellowish ones. And during the first tests, we found principle of the game way too much based on mere chance. So if you place your tokens onto a grid and then a zone plops out of nowhere and you're the winner, you're the loser, or it's a tie, this is boring. Nobody wanted to play that. When we found out that the game was a bit of a bore, we decided to make the zone able to move. And this is how we play it still today. It is still a work in progress. You cannot buy it in the stores yet. But the gaming rules are pretty much set in place. Phase 1, you see the board, you see the zone, you place your tokens. As soon as the tokens are set in place, the zone starts moving. And after each player has in turn moved the zone 3 times, then we count which player has more tokens within the zone. And then it's decided who's the winner and who is not, or if it's tied, which can of course happen. We had pretty much forgotten about the gaming idea. After we did that prototype for the seminar, we got our grade and we were happy with it. But a few years later, we were tasked with writing a master thesis for game studies. And then Markus and I decided to pick up the old idea of CoverZone and create a game from the idea. The rule set was there. We were pretty happy with it actually. And so we decided to get to work. And this is what you can see here. This is my Visual Studio screen. It's the latest version. We, of course, as this was conceived, I think 5 years ago, we did it in an earlier version, if you're wondering. This is Visual Studio 2019, but it's pretty much the same thing if you run it in an earlier version. However, this was one of our first decisions we made. We decided to create the game from what we had. We decided to go for Visual Studio and Unity. Also because Markus is an expert in Unity. I've been developing software in Visual Studio for 15 plus years. This is how the decision came into place. Also, we thought, well, if you want to create something from an idea you conceived in 30 minutes, you should also be able to start from scratch and have a result within not 30 minutes, but let's be reasonable, within 30 days. But if you spend the first 30 days of your project just learning new tools, after 30 days you have nothing. Well, you have knowledge, but you have nothing to show. And perhaps you've even run out of time, out of money. I don't know. So we decided, go for it, but go for it with the tools we know and the tools we love. Okay, so much about history and conceiving of the game. Now let's run it. This is the CoverZone Prototype 1 with full gaming engine, and I will now do two things. I will start a new game and I will switch over to Markus to demonstrate the game for you.
Thank you, Ralph. What you see in the prototype is the gaming grid together with the green cover zone, which was already mentioned before by Ralph. Within the cells of the grid you see some numbers. We will come to that numbers later when we talk to you about the actual purpose of this within the AI. But let's demonstrate a game of CoverZone first. This is the original start of the prototype game, where you see a 12 by 12 grid, a already generated CoverZone. That's the green part of the grid here. As you can see, the CoverZone doesn't have to be in one volume. It can be subdivided in several island zones. We thought that would be more interesting to have a zone like that. This part here, the double ellipse, is the rotation center of the zone. This is where the zone is going to be rotated around and mirrored by. It's actually not even part of the zone. But now let's place some tokens. I'm placing tokens on the grid and let the computer answer with his move. It's even possible to let the computer place tokens for both players to watch the AI playing CoverZone.
We have now finished the first phase of the game and placed our tiles. Before we come to phase 2, moving the zone and deciding a winner, let's talk about why we're actually here. Let's talk about the game's intelligence, or AI if you want. By looking at why did the computer pick which cell to place its token. Let's look at the last of the 5 moves. If you have been watching, the computer placed its final token here. It didn't use this cell, it didn't use this cell, it didn't use this cell. Well, I forgot to tell you one thing. There is a neighboring rule in the game rules which says that you may not use a direct neighbor of your already set tokens to use for the next token. So this cell here, this one here, this one here, they're all currently locked for red. So red is not allowed to place a tile here, as would this cell here for blue. This one would be blocked for blue, this one, this one, this one, this one. You see, illegal move. This is why the computer had to pick a cell of those still available to him. The numbers in the grid, what are those? These numbers, which of course you should not be able to see when actually playing the game as a game and not as an AI demonstration, these numbers are the probability factors of each of the cells to be part of the cover zone after the cover zone has been moved 6 times. So you see, each cell has a value. This one has 134, this one has 107, 129, 21, 0.93, so very low probability to be part of the final cover zone. And this cell has 108, and it was the cell with the highest quotation, evaluation quotation, for the computer to pick when making its move. And this is how this AI works, by a rather simple evaluation process, calculating a probability for each cell, and the computer always picks the cell with the highest value for his move. Phase 2 is now starting, moving the zone. Here, the game's AI has a different task to perform. It has to find the best move with the highest probability of winning the game by getting more of its own tiles into the zone than the opponent. The computer has, of course, to calculate in a certain depth every possible move the zone can make after its own move has been made. This is now a totally different approach towards gaming logics than the placement phase, or phase 1, that we have just finished. We are now going to make some moves. I will move manually, playing as the blue player or player 1. I'm not following any certain pattern or any game logic, I'm just clicking buttons. Whilst the computer will play as red, and I have him play by clicking the computer move zone button here. Then I will go down, have the computer move the zone, and here you can see that the computer chooses a move that puts it into first place. Now I shall click clockwise or counterclockwise. Now the computer will make its final move. It has to move. This is one rule of the game. You cannot skip a move. And obviously, the best outcome for the computer was to play for a tie. Here, the game ends. After a few weeks of programming, we had a playable game. Phase 1 was working, Phase 2 was working, so the computer put its tokens where we pretty much wanted it to do. The computer moved the zone pretty much the way we wanted it to do. But this is when the actual work started, because it was unbelievably slow. Remember, we don't have cloud computing resources available. This is just a desktop game. We used out-of-the-box C#. We had to find out what was going on. And if you create search algorithms going into the depth by using a search tree, you always have to look how many iterations or how many possibilities do you consider before making a move. And this was what we were going to search for in the first place. We found out that the game was playable when we went for a search depth of 4, which meant 4 moves thinking ahead, which also meant 19,000 calculations. This was bearable, but still not what we really wanted. We wanted this to perform better. We wanted this to become more flexible. So we had to come up with something even more sophisticated. To our big surprise, another problem came up, the zone generator. I haven't mentioned this before because we just thought, well, we create a zone and we blotch it onto the game on the gaming grid and then find a way to place our tiles, but we didn't really consider the zone to become a problem. And then when we tried to create zones automatically, they all looked ugly, pretty ugly. And we used several approaches towards a fine and, to our understanding, working zone generator until we came up with a solution to tell the zone generator to create the zone by using chess knight moves. You know, from the chess board game, move 2 steps into one direction, turn by 90 degrees left or right, move a 3rd step. And this technique was used to create the zones by just having it hop around like a chess knight and thereby creating fun and good-looking zones. Well, here's a very short animation of the evolution of our zone generator. And you can see here what I mean by ugly. It placed the zones always around some of the edges of the grid. They were blocky. They didn't have any lightness to them until we finally came up with that chess solution I was telling you about. And this is how it's currently working. Still, there was the problem with the speed of the game, the performance issue. And then we came up with a solution for that as well by eliminating 25% of the available paths by calculating the probability of each path calculated for winning the game, and the 2 least probable ones were dropped. By this, we have 750 iterations with a search depth of 4 moves ahead, 6 moves ahead. We're at 18,000, which is of course still considerable, but much less than before when we were at way over 100,000. And a theoretical, because it's not needed, search depth of 8 is still below 500,000 of iterations, or 2,500% of our desired goal of a search depth of 6. We had of course invested a lot of time in the development of our gaming engine, and now we had the big advantage of being able to transfer our program code from Visual Studio to Unity. Nothing had to be rewritten. Of course, there had to be some adjustments, but only when it came to the interaction between the gaming engine and the visual representation layer. But the whole logics, the whole AI of our game could be transferred easily, and Markus is going to tell you a little bit about this.
Like Ralph said before, we could easily integrate everything into Unity and create some visual pleasing client. At the end, we were able to introduce 3 game modes: human versus human, human versus computer, and on top a network mode where you could play against each other via network. Now let's do a human versus computer game. Choose the skill. We will see some well-known things like the game grid, the cover zone, the center point, and the computer even placed already a token on the game grid. Now let's place some further tokens on it, hopefully better than the computer. Alright, after the first phase I'm leading 3 to 4 and I have 3 moves left. My first thing is I will mirror it. Alright, that looks pretty good. And now let's do the last moves and see who wins the game. Oh no, I lost it. But I promise, next time I will win. Thanks for watching. Back to Ralph.
Well, to wrap things up, thank you for listening. Thank you for having us at this event, for the chance to present our little gaming idea to you. Should you have any questions, Alex and his team can, of course, provide you with the information how to get in touch with us. Until then, take care and enjoy the rest of the day. Goodbye.